So we're doing chapter 5.1, which is, chapter 5.5, which is polynomial and rational inequalities. And just some ground rules here. F of x greater than or equal to 0, and f of x greater than 0, intervals for graph above the x-axis, and f of x less than or equal to 0, and f of x less than 0, intervals below, intervals for graph below the x-axis. So I'm going to sketch a couple of graphs here, and we're going to see if we can figure out what's happening with what we have here. We have f of x, we have x. This is an example. Part A is asking us to find f of x less than 0, and part B is for f of x greater than 0. Now I'm going to highlight in colors what's f of x greater than 0 and f of x less than 0. So we're clear as to what we're looking at on the graphs when we do them. So greater than 0, and I'm using these colors for less than 0. And let's put a graph in here. Perhaps this graph goes through the origin, comes down, and then goes to that way. So this is at 0, this is at 2, this is at 4. For f of x less than 0, we're considering the portions of the graph below the x-axis. And remember, we're writing intervals for these. So from negative infinity up to 0, and from 2 to 4. And for the portion of the graph greater than 0, we're considering the parts of the graph that are above the x-axis. So these parts are going to from 0 to 2, and then from 4 to infinity. Notice the brackets this time. This is greater than or equal to 0. The brackets this time for the equal sign on the inequality. Example. Oops. So we're going to look at this graph. negative infinity, positive infinity, f of x. That point there is -4, this is 0. The first question is asking about f of x greater than or equal to 0, and the second one is asking about f of x less than 0. So for greater than or equal to 0, we're considering the two portions above the x-axis, but it's one continuous graph since the 0 is included because of the inequality symbol. The 0 is included in equality symbol. So we're going from -4 all the way to infinity. And for less than 0, we're just considering the portion of the graph below that portion from negative infinity up to 4, -4. Now, I want you to see that this could be distinctly different if the inequality did not involve an equal sign for similar type of graph for greater than. So here we go. We've got, in this case, this graph does that, and does that. F of x greater than 0 and f of x less than or equal to 0. So the greater than does not have an equal sign this time. We're going to name this point as -5 and 0. And if we're considering intervals greater than 0, we'll consider -5 to 0, and then from 0 to infinity. These two regions here, we can't include 0 this time because the inequality does not have an equal sign. So -5 to 0. And from 0 to infinity. Okay, that is for the portions greater than. And then for less than, we're considering this part of the graph, which is from -infinity up to -5. Now let's try a graph that's open on both ends. Both ends turned upwards, perhaps like this. And we can say this point is -4 and this is +5. So in this case, for f of x greater than or equal to 0, considering the intervals above the x-axis, but including the points. So from -infinity up to -4, and from 5 to +infinity. Okay, again, this is for the portion greater than. Now let's consider less than, which is this piece of the graph. In other words, from -4 to 5. We don't have to worry about brackets or parentheses here because there's no equal sign on the inequality. If the graph has a vertical asymptote or more than one vertical asymptote, then we have other issues to consider because remember the graph cannot intersect the vertical asymptote. So f of x greater than or equal to 0. So this is our blue, this is our yellow. I'm going to do a little graph here. We're going to put in a couple of asymptotes. One at say x is equal to -3 and x is equal to +2. Perhaps we can have the graph intersect at -1. Let's put this part of the graph that way and this part of the graph this way. So this point is -3, this is +2. So less than would be the part of the graph that's below the x-axis, which is this part and this part. Now keep in mind what's happening here, okay? We're describing from -3 to -1, and then from 2 to infinity, from -3 to -1, and then from 2 to infinity. Now this is where it gets a little strange, because above the x-axis it will go from -infinity to -3, and then from -1 to 2. These two regions right here, this and this. So from -infinity to -3. However, -3 is a vertical asymptote, so we cannot use a bracket on it, even though the inequality has an equal sign. -1 is not a vertical asymptote, but 2 is a vertical asymptote. So be careful with your signs here. Look at what's happening here with the signs. This is parenthesis, brackets, parenthesis. Since x cannot equal to -3 or +2. Okay, vertical asymptotes. One more graphing question, and we're going to look at some algebraic questions. F of x greater than 0 and f of x less than or equal to 0. So f of x, -infinity, infinity. Let's give this a horizontal asymptote. Let's say y is equal to 2, and perhaps a vertical asymptote at x is equal to 3. And let's say that the graph intersects at -1. So we have a graph that looks like this, comes down like this, and then this goes that way. So let's mark off what's above and what's below. This is below. There's only this little piece is below. And this portion here is above, as well as this portion. So we have to describe all of this for above. And then this little piece we have to describe for below. So keep in mind this occurs from up to 3 here. Sorry, this is 1, not -1. +1, right? Can't be -1. So greater than 0, we can easily describe the portions of the graph above the x-axis from -infinity up to 1. And then from 3 to +infinity. Now below the x-axis is from 1. 1 is an intercept, so we can just put it in bracket. But 3 is a vertical asymptote. So we have to put it in parentheses, even though the inequality has an equal sign. All right, next we're going to consider a case. This is a problem where we have to factor x cubed minus 6x is less than 0. So to do these type of problems, we would need to perhaps sketch a number line or see what's happening on the number line, and then we're going to do a little table. Okay, this is my number line from negative infinity to positive infinity. We need to factor this, so this is x squared into x minus 6. So the intercepts occur at 0 and 6. 0 and 6. We've got 3 separate intervals here. We've got negative infinity to 0. We've got 0 to 6. And we've got 6 to infinity. So what you want to do is test your values here. Interval, test value, and then you can put above or below. One second here. Okay. Test value and the sign. SIGN. And then above or below. Okay, so we're going to test a value between negative infinity to 0. So let's test perhaps x is equal to negative 1. So that would be, we're substituting with negative 1 cubed minus 6 times negative 1. And if we work that out, we get a negative number. Negative number. Negative 7 to be exact, but that's not important. That means it's below. Since we're looking for below, then if we test it from the interval 0 to 6, if we test positive 1, we get 1 cubed minus 6 times 1, which comes out to be negative 5, which tells us it's below also. And then from 6 to infinity, we can perhaps test x is equal to 7. 7 cubed minus 6 times 7 gives me 7, that's 49. You know, I've been doing this wrong. This should have been x squared. So this is squared. And this comes out to be 49, which is positive, which means it's above. So the question is asking about less than. And so to answer this question, we're looking about the two portions that are below the x-axis from negative infinity to 0, and from 0 to 6. In other words, these two right here below. Okay, I want you to see the sign works on this. The sign is all negative in this, negative here, and then positive here. FYI, if this question had been x cubed minus 6x squared greater than or equal to 0, it would have been the portion above, and the solution would be from 6 to infinity. If the equation is already factored, such as x minus 5 squared, x plus 7 is less than 0. So x is equal to positive 5 and x is equal to negative 7. We've got negative infinity to negative 7 to 5 to positive infinity. So we've got four intervals here: negative infinity to negative 7, sorry, 3 intervals, negative 7 to 5, and from 5 to infinity. Make up your little table. Intervals, test, sign above or below. So you can probably test a number that's less than negative 7, so x is equal to negative 8. Substituting in the original equation, I have negative 8 minus 5 squared negative 8 plus 7, which is clearly a negative number, so below. Then I can test a number between negative 7 and 5, say 0. So 0 minus 5 squared, which is positive, and then 0 plus 7, which is also positive, so above. And then test a number that's greater than 5, so perhaps x is equal to maybe 7 or 8 or 6 or whatever you want to choose. I'm just going to go with a number that's right above. So 6 minus 5 squared, 6 plus 7, which is also a positive number, so it's above the x-axis. So we have above, and then below. And you can see the signs for that: minus, 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 plus, 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 plus. So this is above, but the question is strictly asking about below the x-axis, so the solution would be from negative infinity up to negative 7. Again, an FYI, if we were asking about above the x-axis, let's say x minus 5 squared, x plus 7, let's say this was greater than or equal to 0, we will be naming the portions that are above the x-axis from negative 7 to 5. and then from 5 to infinity. Actually, this would be all the way across, because this that's not correct. From -7 all the way through to infinity. Yeah, that's correct. All the way to infinity, because the 5 would be included in the inequality. And even though it's touching at 5, it's included in the inequality. Now, this gets a little hairy if we have to consider an inequality a rational inequality. But the process is pretty much the same. Let's say we've got x plus 6 over x minus 9 less than 0. So we know there's an x-intercept that where the graph crosses at x is equal to -6, and then x cannot equal to 9. So both of these points have to be on the number line when we're making up that number line. From negative infinity, positive infinity, we'd have something at -6 and something at 9. And now we have to test some intervals here, because so interval test sign above or below. We're testing from negative infinity to -6. So we can test, say, x is equal to -7. So -7 plus 6 over -7 minus 9 is a negative number. Is it? No, it's negative divided by negative, so it's positive. So this is above. Then from -6 to 9, we're going to test 0. 0 plus 6 over 0 minus 9, which is negative, which is below. And from 9 to infinity, we're going to test 10. 10 plus 6 over 10 minus 9, which is positive, which is above. So that kind of defines what we want here, right? Because this is sorry, that's the color for above. This portion of the graph is above, and this portion is below. However, keep in mind that 9 is a vertical asymptote. So for the solution here, we're asked about the part that's below the x-axis from -6 to 9. And if the problem had been x plus 6 over x minus 9, FYI again, greater than or equal to 0, we'll be talking about the portions of the graph that are above the x-axis. But this 6 would have a bracket, and the 9 would have a parenthesis, because 9 is a vertical asymptote. So careful with this. Okay, I'm giving you both scenarios because the question might ask you for greater than, or it might ask you for less than. All right, the final type of problem that we have to consider is if the inequality is not set equal to 0, such as x plus 20 over x minus 16. And let's say in this case here, it's given as greater than or equal to 1. So you would have to rewrite this inequality so that it's set equal to 0. So you would start by taking away 1 from both sides, so this becomes -1 is greater than or equal to 0. Then use your algebra to create the same common denominator. Okay. In other words, we're combining this into one fraction, x minus 6, x plus 20. They now have the same denominator. Distribute the -1. We have negative x plus 16 is greater than or equal to 0. And this is, x's cancel out, so this is 36 over x minus 6 is greater than or equal to 0. 16. So the only point we have to consider is that x cannot equal to 0. That's the vertical asymptote. X cannot equal to 16. That's the only interval on the number line to consider. Negative infinity, infinity. So we're only going to test from negative infinity to 16, and then from 16 to positive infinity. Okay, interval, test, sign, above or below. So testing a number between negative infinity to 16, we can probably test, say, what, x equal to 0. That's a good number. X is a number that's less than 16, but gives me, if I'm testing in here, 36 over 0 minus 16, which is clearly a negative number, so below. Then if I check a number that's greater than 16, say x is equal to 20, I have 36 over 20 minus 16, which is a positive number, so this is above. So we can see that this above is from 16 to infinity, and below is from negative infinity to 16. Now let's see what the problem is asking for. The problem is asking for greater than, so it's want the solution for above. So solution from 16 to infinity. Now, although it's greater than or equal to, we have to put the 16 in parenthesis, since x cannot equal to 16, because 16 is a vertical asymptote. FYI, if the question was asking about x plus 20, x minus 16, less than or equal, sorry, less than 1, the solution would be from negative infinity to 16. So again, pay attention to which one it's asking for, greater than or less than, and that concludes our class.